morning to everyone. Myself Sujatha, working as Assistant Professor in MLR Institute of Technology, Hyderabad. In this session, I am going to discuss maxima and minima for function of two variables. So first we will see what is the definition of the maxima and minima. Next we can see what is the working procedure to find out the maxima and minimum for function of two variables. Problem related to the maxima and minima. First, we will see what is the definition. Maximum value. What is maximum value? So, if the function is f of x comma y, f of x comma y has maximum at the point a comma b, if f of a comma b is greater than f of a plus h comma b plus k. So, h comma k are the neighboring points of a and b. Next, minimum value means f of a comma b is less than f of a plus h comma b plus k. So, extreme value means if the function f of x comma y has either maximum value or minimum value, we can say that that function is set, that point is said to be extreme value. So, first we will see the working procedure, how to find out the maxima and minimum for the two variables. Two variables means function of x comma y. Function of two variables means f is function of x comma y. So, if they are giving the function of x comma y, how to find out the maxima and minima? Before that one, suppose if it is a function of single variable f of x, how to find out the maxima and minima? First find out the f dash of x. First find out the f dash of x. Next find out the f double dash of x. First f dash of x is equal to 0. We are getting the points of x. If substitute this point of x in f double dash of x, if it is greater than 0, we are calling as that is minimum value. And if it is less than 0, we are calling that is the maximum value. So, this is a function of the single variable. Suppose if it is a function of two variables f of x comma y, we will see how to find out the maxima and minima. First find out dou f by dou x. First find out dou f by dou x. Next find out dou f by dou y. So, dou f by dou y x means differentiate this one partially with respect to x. Dou f by dou y means differentiate this one partially with respect to y. Next equate to 0. So, dou f by dou x equal to 0 and dou f by dou y equal to 0. After that, solve these two equations. We are getting the points. Depends on the problem, we will get the 2 points, 3 points, 4 points, 5 points. So, that's all. A1, B1, A2, B2, so on. So, these are the points. We can call these points are called the stationary points. Stationary points. This is the first step. First find out dou f by dou x, dou f by dou y. Next find out the stationary points. Next, after finding the stationary points, next thing is we have to find out dou square f by dou x square. So, instead of writing dou square f by dou x square, for our convenience, we are writing that is some letters, that is R, S, T, R, L, M, N, anyway we can write. So, R means dou square f by dou x square. Next one is S. S means dou by dou x of dou f by dou y. So, this is equal to dou square f by dou x dou y. So, we can call that is S. Next T. T equal to dou by dou y of dou f by dou y. So, this is dou square f by dou y square. So, first find out R value, next find out S value, next find out T value. Next calculate RT minus S square, each and every point. RT minus S square, each and every stationary point. Suppose if you are calculating RT minus S square at the point A1 comma B1, if it is greater than 0, compulsory the function has either maximum or minimum. So, if it is greater than 0, next check out R. If it is R, if R is greater than 0, we are getting the minimum value. If r is less than 0, we are getting the maximum value. So first check it, rt minus s square greater than 0. If it is rt minus s square is greater than 0, compulsory the function has either maximum or minimum. So depends on this r value. So r is greater than 0, r is greater than 0, r is greater than 0, we will get the minimum value. R is less than 0, we will get the maximum value. Next one is, if it is rt minus s square equal to less than 0, the function has neither maximum nor minimum. So at the point a1 comma b1, so this point is called the saddle point. This point is called the saddle point. Next condition is rt minus s square. Rt minus s square equal to 0. So we can't conclude about the either maximum. We can't conclude. We need further investigation. This is the procedure for maxima and minima. First, find out the stationary points. Next, find out RST. RT minus S square is greater than 0. The function has compulsory maximum value or minimum value, depends on the R. R less than 0, maximum. R greater than 0, minimum. If RT minus S square is less than 0, so the function has neither maximum nor minimum. That point is called the saddle point. RT minus S square equal to 0. We can't say anything about the maxima and minima. We need further investigation to check the maxima and minima. This is the procedure for function of two variables. Take a we can see one problem related to the maxima and minima. So this is the problem: x power 4 plus y power 4 minus 2x square plus 4xy minus 2y square. So this is function of two variables. That's why you can call this is f of x comma y. F of x comma y equal to x power 4 plus y power 4 minus 2x square plus 4xy minus 2y square. First find out dou f by dou x. Dou f by dou x. With respect to x, we have to treat y is constant. Derivative of x power 4, 4x cube. Derivative of y power 4 with respect to x, that is constant 0. Derivative of minus 2x square, that is minus 4x. Derivative of 4xy, that is 4y. Derivative of 2y square, 0. Next, find out dou f by dou y. With respect to y, we have to keep yx is constant. Derivative of x power 4, 0. Y power 4, 4 into y cube. This is minus 2x square, constant 0, plus 4xy with respect to x, that is 4x plus 4x. So next minus 4y. Derivative of 2y square is 4y. Minus 2y square is minus 4y. Next thing is we have to equate to 0. So this is, so each and every term containing 4, that's why common 4, we are getting 4 into x cube minus 4 minus x plus y equal to 0. So here also same. So each and every term containing 4, 4 is common. Y cube plus x minus y equal to 0. So take this equation is 1 x cube minus x plus y equal to 0. So take this is an equation 1. Next one is y cube plus x minus y equal to 0. Take this is an equation 2. Solve these two equations. Add this one, we are getting minus x plus x cancel, plus y minus y is cancel. We are getting x cube plus y cube equal to 0. So we have the formula for this one, a cube plus b cube. What is a cube plus b cube formula? A cube plus b cube equal to a plus b into a square minus ab plus b square. We have to use this formula. So we are getting x plus y into x square minus xy plus y square equal to 0. So one of the root is x equal to minus y or y equal to minus x. So this is the relation of x and y. Next, find out the stationary points. When x equal to 0, when x equal to y, when x equal to minus y, in equation 1, what we are getting in place of x cube? So minus x. So in place of y, we can write minus x equal to 0. So this is x cube minus 2x equal to 0. So x is common, we are getting x square minus 2 equal to 0. So x equal to 0 or x square equal to 2. X square equal to 2 means x equal to plus or minus root 2. So these are the points of x 0 or x equal to plus root 2 or minus root 2. When x equal to 0 implies if x equal to 0, substitute x equal to 0 in this one, we are getting y value is 0. Y value is 0. When x equal to root 2, y equal to x equal to minus y. So x equal to root 2, y equal to minus root 2. Next one is x equal to minus root 2, y equal to root 2. Therefore, stationary points are so x 0, y 0, 0 comma 0, x root 2, y minus root 2, that is 2 comma minus root 2. Next one is x minus root 2 comma root 2. So these are the stationary point. For each and every point we have to find out RT minus S square value. First we can find out R value. R equal to dou square F by dou X square. That is dou by dou X of dou F by dou X. That is dou by dou X of dou F by dou X. Dou F by dou X value is 4x cube minus 4x plus 4y. Minus 4x plus 4y. So this value is with respect to x. 4x cube, 12x square minus 4x, 4. Yes, S value is dou square F by dou X dou Y. So this is dou by dou X of dou F by dou Y. This is dou by dou X of dou F by dou Y. Dou F by dou Y value is 4y cube plus 4x minus 4y. 4y cube plus 4x minus 4y. So this is equal to 12y square minus 4. Next t value we have to find out. Dou square F by dou y square. Dou square F by dou y square is dou by dou y of dou F by dou y. This is dou by dou y of dou F by dou y. So this is the dou F by dou y value. 4y cube plus 4x minus 4y. Derivative with respect to y. That is, this is derivative with respect to x. Derivative with respect to x is, this is 4. With respect to x, 4y cube 0 minus 4y 0. Derivative of 4x is 4. So this is 12y square minus 4. So next find out RT minus S square. RT minus S square. RT minus S square is 12x square minus 4 into 12y square minus 4 minus s square. S value is 4, that is 16. So for each and every point we have to find out the rt minus s square. First stationary point is 0, 0. So at 0, 0 we can find out. So if it is 0, x 0, so this value is 0, that is minus 4. Minus 4 into minus 4, that is 16. Minus 16, that is 0. Here x 0, so this value 0, minus 4. Y 0, this value 0. We are getting minus 4. Minus 4 into minus 4, 16. 16 minus 16 is 0. Next, rt minus s square at the point. Next point is, this is root 2. Root 2 comma minus root 2. Here is x is root 2, y equal to minus root 2. Root 2 comma minus root 2. Root 2 comma minus root 2. So substitute x equal to root 2, x square equal to 2. So 12 into 2, 24. 24 minus 4, 20. So here is also same, minus root 2 whole square, that is 2. 24 minus 2, 20. Minus 16, that is 400 minus 16. Whatever the value that is positive, that is greater than 0. Next, rt minus s square is greater than 0. The function has either maximum or minimum, depends on the r value. Immediately we have to find out the r value at the point root 2 comma minus root 2. So what is r value? 12x square minus 4. So if you substitute x equal to root 2, that is 12 into 2, 24 minus 4, that is 20. 20 is greater than 0. Therefore, rt minus s square is greater than 0 and r is greater than 0. Therefore, f has minimum at the point root 2 comma minus root 2. Next, we have to find out rt minus s square. Rt minus s square at the point minus root 2 comma root 2. So this is equal to, here also same, minus 2 whole square, 2 minus 2 whole square is 2. 24 minus 4, 20. 20 into 20. Minus 16 greater than 0 and r minus 2 comma root 2. Minus root 2 comma root 2, that is also 20 greater than 0. Therefore, f has minimum at the point minus root 2 comma root 2, also the function has minimum. Rt minus s square greater than equal to 0, that is need further investigation. Therefore, the function has minimum at the point. Therefore, f has minimum at the point at the points root 2 comma minus root 2 comma minus root 2 comma root 2. So this is a procedure to calculate maxima and minima for function of two variables. Thank you.